Good day everyone. Today we will explain to all of you about the Earth's minerals and processes. The concept of mineral is distinct from rock, which is any bulk solid geologic material that is relatively homogeneous at a large enough scale. A rock may also consist of one type of mineral or may be an aggregate of two or more different types of mineral.
Good day everyone. My name is Marco and today I will be explaining how rock-forming materials can be identified using physical and chemical properties. The physical properties of minerals are determined by atomic structure and crystal chemistry of the minerals. The most common physical properties of crystal form are color, hardness, cleavage, and specific gravity. One of the best ways to identify a rock material is by examining its crystal form. As for chemicals, you can identify the rock using color, streak, hardness, and cleavage. And I will be explaining how sedimentary rocks are formed. Sedimentary rocks are formed from deposits of pre-existing rocks or pieces of living organisms that accumulate on the Earth's surface. If sedimentary rocks are buried deeply, it can become compact and cemented, forming sedimentary rock.
Thank you, Marco, for explaining to us how to identify rocks with physical and chemical properties, as well as how are sedimentary rocks formed. My name is Marco Abella, and today we will be answering two questions. How are igneous rocks formed, and how are metamorphic rocks formed? First, we'll answer how are igneous rocks formed. There are two types of igneous rocks: extrusive rocks, where it is formed in the surface of the earth. Intrusive rocks is formed deep in magma. Metamorphic rocks are formed through three factors: high pressure, high heat, or rich mineral salt fluids, or more commonly, a combination of the three. It is mostly formed around the tectonic plates.
And now that we haven't already discussed how the igneous rock and metamorphic form, so let's proceed. So I'm the one who will discuss how rocks behave under the different types of stress and the evidence of the continental drift. So without further ado, let's get started. First, how do rocks behave under different types of stress? Stress is a force acting on a rock per unit. It has the same unit as pressure, but also it has direction. There are three types of stress. First, compression. This is a stress which causes rock to squeeze or push against the rock to each other. Second, tension. It is a stress which occurs when rock pulls apart or gets longer. Lastly, shear. It is a stress which occurs when tectonic plates move past each other, causing rock to twist or change shape. Let's move into the next question. What are the lines of evidence of continental drift theory? They are based on the idea of continental drift on several lines of evidence. Feet of the continents, plate climate indicators, truncated geologic features and fossils. There are four pieces of evidence of the continental drift, include continents fitting together like a puzzle, scattering and ancient fossils rocks, mountain ranges, and the climate zone locations.
Good day everyone, my name is Trisha. Since Hannah is done explaining, now I'll explain to you what are the different results of the environment of plates are. Then there are three types of movements: the tectonic plates, convergent, divergent, and transform. Convergent plate boundaries move towards each other. The denser mantle goes under the other mantle. This is called subduction. Divergent plate boundaries move away from each other. And lastly, the transform plate boundaries vary from each other. Do you know how the age stratified rocks is identified? The age of rock is determined by radiometric dating, which looks at the proportion of two different isotopes in a sample. Radioactive isotope breaks down in a predictable amount of time, enabling geologists to determine the age of sample using equipment like this thermal ionization mass spectrometer.
Hi, my name is Victor and I will be the last one to present you about the different result of the movement of plates. Index points hence to the relatives time scale are the example of change points. The form of light is excited during limited period of geology time and those are used as guides to the age. The rocks in which they are preserved. Tall Earth historically interpreted from the geology time scale. The geology time scale was developed at the size speeds observed changing the point going from oldest to youngest cementing rocks. Later, scientists used absolute dating to determine the actual number of years ago. That ever happened. Biology time scale is divided into eons, eras, units, and
We hope to everyone that the things that we have shared with you today help you and will be able to guide you in the near future. Make sure to share this video to your friends if you found it helpful. Have a nice day and goodbye.